Friends, welcome. In this session, I will talk about a very simple term, formal charge, which is in the curriculum of 11th standard. Sometimes we are confused, we learn very well in 11th or 12th, but later on that becomes very dull in our mind. Because when I taught reactive intermediates, I took three carbocation, carbanion, free radicals. Then some query was there of undergraduate level that, sir, why you have put negative charge carbanion on carbocation that is positive, on free radical that was neutral. I thought it is better to explain the term formal charge, which you can consider forever for the basics of chemistry. The word is formal, means there is charge, but that is formal. What is opposite to formal? That is actual. Means some charge which is not actual, but that is a formal. That is a formal charge. Charge on any atom in a molecule which is not actual, but that is a formal. Suppose I have to define the formal charge. In words I can define, that is formal charge is the difference between the valency shell electron of any element minus total number of electrons assigned by the Lewis structure with that atom. So what is formal charge? Difference between the valency electron of any element. Suppose an element, independent element, sulfur, there are 6, nitrogen, there is 5, carbon, there is 4. So these are valency electron. Valency electron minus number of electron assigned to that atom, according to Lewis structure. Whenever you will calculate the formal charge, you cannot remain without Lewis structure. So I can say that is a concept of covalent compound, I can say. So formal charge, now I will write formal charge Fc, number of valence electrons, minus, now I will differentiate here, number of non-bonding electrons, minus half the number of bonding electrons. So friends, what I did say earlier in words, difference between the valency electron and the electrons assigned to that atom in a molecule according to Lewis structure. But if I go in further detail, when I will come to example, you will be very much familiar. Valency electron, I did say, total number of electron present in the outermost orbit. Suppose carbon 4, nitrogen 5, oxygen 6. Number of non-bonding electron, lone pairs, kitne hain? Then half the number of bonding electron, right? Second thing, I did say in the beginning, now I will justify, actual charge is not there, that is formal. Why it is known as formal charge? Reason is that whenever you calculate the formal charge, you never consider the electronegativity. Suppose that is between carbon and carbon, oxygen and oxygen, you will consider half the number of bonding electron. If you take the carbon dioxide, sulfate ion, between sulfur and oxygen, carbon and oxygen, you will not consider the high electronegativity of oxygen. Just you will divide the bonding electrons in two atoms equally. Now I come to any example. Suppose I take the example of carbon dioxide. This is carbon dioxide, right? I did say whenever I have to calculate the formal charge, I cannot escape from Lewis structure. This is the Lewis structure. There are 4 valence electrons in carbon, 2 are sharing with oxygen, towards sharing with this oxygen. There is no any lone pair on carbon atom, but we are looking two lone pair on each oxygen. Suppose first I calculate the formal charge of carbon. Formal charge of carbon. Then what will be that? Number of valence electron 4, right? Minus number of non-bonding electron, I am looking 0. There is no any non-bonding electron. In oxygen there are two lone pair, but carbon doesn't have any lone pair. All the 4 electrons, they are engaged in bond formation. So valence electron 4, number of non-bonding 0, minus half the number of bonding electrons. How many bonding electrons are there? 2 bond, 4 bonding electron, 4 this side. 8 divided by 2. So I can say formal charge of carbon is equal to 4 minus 4 is equal to 0. Formal charge is 0. Suppose I calculate the formal charge of this oxygen. Suppose this is A, this is B. I take the formal charge on B oxygen atom. B oxygen atom. What is the formula? Number of valence electron. The number of valence electron in oxygen, that is 6. 6 minus non-bonding electron. In this, I have to look only this oxygen atom. There are 4 non-bonding electron. 2 lone pair means 4 non-bonding electron minus half the number of bonding electron. 4 bonding, 4 divided by 2, that is formal charge is equal to 0. So oxygen formal charge 0, carbon oxygens are 0. Similarly, this oxygen is also identical. Valency electron 6 minus non-bonding electron 4 minus half the number of bonding electron, that is 0. So because carbon dioxide is a neutral molecule, the net formal charge on each oxygen atom will be 0. Right? Because in a neutral molecule, you don't have any charge. That is a molecule, not ion. So the net charge on CO2 will be 0 and you are not looking any charge. So this is formal charge on carbon. Once again I will repeat. Number of valence electron 4 minus number of non-bonding electron 0. Half the number of bonding electron 8 by 2 4 0. Any oxygen you can take, both are identical. Group number or valency electron, old group number, whenever you say, because according to modern periodic table there are 1 to 18. So if we say old group or valency electron is the correct term, 6 minus non-bonding electron 4 minus bonding, half the number of bonding electron 4 minus 2, that is 6 minus 6 minus 4 minus 2, that is 0. So formal charge on both oxygen and carbon, that is 0. Now I take another example so that you can understand in a more better way. I am taking a very interesting example that will help to understand you. That is sulfate ion. How we write sulfate ion? SO4 2 minus. So suppose I have to calculate, I have to justify that sulfate ion is 2 minus. How can I justify? Only through formal charge. First I will write the Lewis structure. That is a must requirement, I did say. There are 4 oxygen, 2 doubly bonded with 2 lone pair, 2 oxygen singly bonded with 3 lone pair. You are looking, there are 3 lone pair, right? First of all, I will calculate the formal charge of this sulfur atom. So formal charge on sulfur. What is formal charge? Group number 6 minus non-bonding electron 0. No lone pair is there. So I will put 0 minus. Suppose I am taking sulfur. So how many bonding electrons are there? 4 plus 4, 8, 10, 12. 12 upon 2. That is 6 minus 6 is equal to 0. So the formal charge on sulfur is certainly 0. Group number 6, non-bonding electron 0. Half the number of bonding electrons. These are 4 bonding. One bond with 2 electron, another bond with 2. 4 plus 4, 8 plus 2 plus 10, 12. Right? Now I will calculate any of these oxygen. I will put AA. Formal charge on any oxygen A. This is oxygen B, I will say, right? Now suppose I am calculating formal charge on oxygen A, right? Group number 6 minus non-bonding electron 4. You are looking in both oxygen 4 non-bonding electron. 2 lone pair means 4 non-bonding electron. 6 minus 4 minus half the number of the bonding electrons. How many bonding electron in both the cases? 4 bonding electron. 4 divided by 2. So what you are getting? The formal charge 0. Formal charge is 0. Similarly, suppose now I come, these are identical, B oxygen atom. Formal charge on oxygen B, right? What is valence electron? 6. Minus, now in this case of A, there were 4 non-bonding electrons. Now you are looking 3 lone pair means 6 non-bonding electron, right? Minus half the number of bonding electron, minus 2. So 6 minus 8, the formal charge is minus, I'm sorry, just look, I should repeat. Group number is 6 minus 6. Oh, that is divided by 2. So 6 minus 6 minus 1. That is formal charge. I am sorry. I have rectified it. Because group number 6, non-bonding electron 6, these are 2. So I will divide 2 by 2, half the number of bonding electron. So 6 minus 6 minus 0, I can say the formal charge is 0. That will be, sorry, I'm sorry again. Let me rectify it. Because there is 1. So the formal charge will be minus 1. Formal charge will be minus 1 on any oxygen. So I can say this oxygen 0, this oxygen formal charge 0, sulfur is 0, this is minus 1, this is minus 1. Now you calculate the net charge. Forget whatever the sulfate bears the negative charge. You calculate according to Lewis structure, and this oxygen is minus 1, this is minus 1 formal charge, minus 1, you are looking 2 minus formal charge. So once again I will repeat sulfate ion. This is Lewis structure of sulfate ion. 2 oxygen are doubly bonded, 2 are singly bonded. 2 doubly bonded have 4 non-bonding electron, singly bonded 6 non-bonding electron. So suppose I calculate the charge of sulfur, that is group number 6 minus non-bonding electron 0 minus half the number of bonding electron. 4 plus 4 plus 2 plus 2, 12. 12 divided by 6, 6 minus 6, 0. So formal charge on sulfur is 0. I calculate the formal charge on any of doubly bonded, which I have denoted by A. Group number obviously 6 minus non-bonding electron, 2 lone pair means 4 non-bonding electron, minus half the number of bonding electron, 4 divided by 2, and you will find the formal charge of doubly bonded oxygen is 0. But when I come to this lower B oxygen, you see group number same 6, non-bonding electron. In doubly bonded they were 4, but in singly bonded, because this is already have negative charge, so 6 group number minus 6 non-bonding electron minus half the number of bonding electron. 2 electrons divided by 2 is equal to 1. 6 minus 7 -1 formal charge is present on the sulfur which is singly bonded. So ultimately -1 -2, you are looking 2 minus charge on sulfate ion. So any charge you can take phosphate ion, PO4 3 minus, or borate ion. How these 3 minus or 2 minus or simply minus chloride you can take very easily, you can calculate. I hope we should be clear. That is a formal charge because we are not considering the electronegativity. Oxygen is much more electronegative. Oxygen is much more electronegative than sulfur, but we are dividing the electron equally. In formal charge, we are not considering electronegativity. That is not the actual charge. That is formal charge. So formal charge, which is the difference between the valence electron of that element and the total number of electron of that atom. Suppose I am calculating the formal charge of oxygen A. So these are the total number. 4 non-bonding plus 4 bonding. So I will take 4 bonding plus half the number of 4 non-bonding, half the number of bonding, 4 divided 2. I hope it will be quite clear. If you need any help, kindly comment in the comment box.